Will I be able to take this cheap pneumatic press and turn it into a fancy injection molding machine? Can I build a CNC and learn enough about die making to make something for Christmas? What am I doing? Have you ever watched a video and you think, oh my gosh, this is going to eat the next few months of my life? That happened to me. I was watching a video by Buster Beagle 3D where he was making an injection molding die using one of those tiny 3018 CNCs. Now, I'd always dismissed those things as kind of toys, but here he was getting real work out of them. So I thought, I gotta check this out. Little did I know this was gonna be the start of a whirlwind romance. I got rid of the original motor and put in this 500-watt brushless one. And I put fatter 12mm rods on the x-axis. I redesigned the X and Y carriages. Then I designed a laser cut enclosure to cut down on the noise and mess of running a CNC right in your shop. I really liked the way it turned out. Pretty soon I was making things and having a lot of fun, but I still hadn't made any injection molding dies. Was the machine gonna be up for it?
We lost power. Like I'm only 10 minutes from the end of this thing and we lost power.
Well, after one more try where our power stayed on, I managed to make what seemed like a functional injection molding die. Like it looked pretty good. I couldn't wait to try it out, but I was now in the weird situation of having made a die, but not having an injection molder. So I decided to build one of the Buster Beagle injection molding machines. And the thing was great. It's like lightweight, cheap, easy to build. It checked all the boxes. Well, there was one important box that remained unchecked, but I'll get to that in a second. But why injection molding? Well, I hadn't really needed a whole lot of parts before. Injection molding is great if you need a lot of parts, but if you only need one or two parts, 3D printing is probably better because you can just print out one part and off you go. It's like a lot simpler than having to make a die and have a machine, blah, blah, blah. When I was working on the computer-controlled loom, though, I had to make hundreds of parts for that thing. When I redesigned the way the hooks were, I literally had to print 120 more of these little hooks, and it would have been great if I'd had an injection molding machine because I could have remade them in an afternoon as opposed to spending a week printing parts. Which brings us back to that missing checkbox on the hand injection molding machine. Consistency. When I make 120 parts for something like the loom, I need them to all be identical. When I started using the manual injection molder, I quickly learned that there's a lot of technique involved. You have a lot of different variables, how long the plastic has been in the chamber, how warm the mold is, how fast you pull the lever down, how long you hold, how much pressure you use, can make slight changes in your injection. And a lot of failures and wasted plastic, frankly. I realized that with that machine, if I really needed to make 120 hooks, it was gonna really hurt my arm and I was gonna take a long time. Now there are fancy semi-automated injection molders that are pneumatic. And I was drooling over those on eBay, but boy, even a used one is like thousands and thousands, like $7,000 or more. And I was like, that is never happening. But as I was poking around, I also noticed that there were these pneumatic punch presses. And to me, they look kind of similar. Like this pneumatic punch press has a big pressure cylinder, and really it was all it needed was a heating chamber and a thermostat, and it would practically be an injection molding machine. So I looked at the punch presses, and I looked at the injection molding machines, and I was like, could I add that? It seemed like it was worth a shot. I tried to get my friends to talk me out of doing it, but they were unsuccessful, so I went for it, and I ordered one off eBay. Little did I know what I was in for. Well, the thing was a mess. As the seller said, we were all victims of rude transport. I was kind of amazed that it arrived in a cardboard box. I was assuming something weighing 90 kilograms should come in a crate of some sort, but I tested the cylinder out and it was free moving, so I decided to press on. I also needed to machine a part out of 1/2-inch stainless. And so I ran some tests on my CNC and surprisingly was able to do it. But to machine a big chunk of stainless in my itty bitty CNC was going to take forever. So I decided to just lay it out by hand and make this part the old-fashioned way.
Welcome to Pneumatic's tower. My mission is to pull up these tie rods so the new spacer rods could be installed below the cylinder. Okay.
Now, one of the few accurate things you have to do in this whole deal is I have to mount the heating chamber centered below the pneumatic cylinder. And in order to arrange that, you can't just center it on that rough casting in the top of that thing, because that's not accurate. You have to center it relative to the mounting holes for the cylinder. Now, that's a little bit tricky. You can't just draw an X across from the mounting holes because that's floating out in the air over that hole. So how the heck am I going to position this thing? Well, luckily, thanks to the magic of 3D printing, it's pretty easy to print a little jig.
So the plan for the press is to raise the main air cylinder up by adding these 4 spacer rods. Then I can use a stock Buster Beagle V2 heating chamber, and the custom collar I made can be used to mount it under the press. Plastic beads can be loaded into the top of the chamber where they melt. When the cylinder fires, it pushes the plastic out the small hole at the bottom of the chamber with a great deal of pressure. The heated, pressurized plastic squirts into the die and then cools. I thought the heating chamber could just float on these springs, but in the worst-case scenario, all the force of the press would be crushing them in a dangerous way. So I had to make a couple more parts. The chamber can still move, but these standoffs take up the load and prevent the springs from ever being fully compressed. So let's wire up the heating bands, put on the thermostat housing, and wire up the temperature sensor. Well, here goes nothing. Wait, did you see that? That could have been a lot worse, I guess. This looks like a job for the shortenator. Well, here goes. Remember, at times like this, it's important to use your safety glasses. Oh no, the heating chamber didn't descend. At least you can tell the shot size is fairly large. I guess I'm gonna have to clean this up. Let's see if we got anything in the mold. Well, not a complete fill.
All I had to do was unscrew those mounting bolts a little bit so that the mounting springs weren't as pre-tensioned, and then everything worked fine. I made a few other little improvements, and here it is in action. Well, the injection molder was a success, and thanks to adding both some adjustable exhaust baffles and the built-in electronic controller, it now has control over injection pressure, injection speed, hold time, release speed. So it's really a very repeatable process, and I had a lot of successes in a row. I think making a lot of successful injections is pretty easy, and I don't have to act like a gorilla and end up with a sore arm if I'm going to make a couple hundred parts. I timed myself, and at maximum speed making those logos, I could do about an injection every 30 seconds. But I have to admit, that's removing the plastic while it's still pretty hot, and I was starting to burn my fingers. So I bet maybe 40 seconds or wearing gloves might be a more practical limit, but it really did a great job. You might be wondering, what happened to the Christmas project? I thought you were going to do a Christmas project. Well, I got the injection molder working on December 18th. So there were still a few days left. I thought maybe I could still do this.
10 years ago, I designed these Moomin cutters. They were laser cut from acrylic, and although they came out pretty nice, they were pretty fragile. An injection molded cutter would be much tougher and easier to clean. I could do the top of the plunger and the detail stamp as one die, and the outer cutter as another die. But with only a few days left before Christmas, I needed a design now. Thankfully, back then, I designed this little My cutter, but had run out of time and hadn't given any away as gifts. 10-year-old design to the rescue. When I tried to machine the first of the 2 dies for the Christmas project, I ran into a whole series of failures. Or, I guess, learning experiences. So although I was learning a lot, I wasn't making any progress on the Christmas project and time was running out. And this was supposed to be the simpler of the 2 dies. I did eventually get a decent version of the first die made, but then I ran out of time.
Well, so ultimately the Christmas project was a little bit of a bust. I ran out of time, which was not surprising. I knew that a mold of that complexity was going to be pretty difficult. I will say that I'm super happy with the results of the press. I think the only real downside now is that it was a little bit more complicated to build than I'd hoped. Now, I'd kind of been hoping, you could just have these 4 rods and this collar, and everything else is just off the shelf and you drill and tap a few holes. But when I did the CAD model of the press, I didn't measure it super well, and it turns out the collar doesn't quite fit under the casting as is, and I ended up having to machine a little pocket out of the bottom. And that's kind of a bummer because not everybody can do that. So that's like one thing that isn't very kit friendly. But hopefully you guys can build one. I really recommend it. It works great. I really think if you're going to make a lot of parts, this is the way to go. So I'll put all the details up, including injection pressure, maximum shot size, all that stuff. It's all down in the doobly-doo. And I'll also do a cost breakdown, including all costs, including taxes and shipping and blah, blah, blah. I'm happy to share all the designs. I'll put up the design files, the 3D prints, everything, so that if you build one, let me know, because I really think this is a great way to go.